Welcome. This is 5.4 applications. So we've been talking about linear equations in different forms, whether they be standard form, slope-intercept, or point-slope. So we're going to work on some two-word problems, and if you have any questions, just let me know. Okay. So on your notes, it's a little off. This part that says example 1 is like on the top or the previous page, so just be aware of that. Okay, so it says Jack reads a book cover to cover in a single session at a rate of 55 pages per hour. So here's a key word, is per. After 4 hours, he has 385 pages left to read. Okay. So this would be a point, would be 4,385. Talking about units, if we had a graph, let's make a little graph, what would be our x unit and what would be our y unit? Okay, so x, remember, if we have time, hours, minutes, seconds, days, years, that's always going to be your x-axis, okay? Because time is always independent. You can't change time. So we'll do something like hours. And then the what y represents, well, y represents would be the pages. Okay, so we're talking about hours, we're talking about pages. Okay. We're not sure how many pages are in that book, but we want to get to the point where we have no pages left. So they tell us after 4 hours, there is 385 pages left. Okay, so we're going to have some sort of a linear equation that is modeled by that. Okay, so if you need to see that a little better over there. Okay, so the first thing I think they ask after that is, what is the rate of change? Okay, rate of change, another way to say that would be slope. So what is the slope of this problem, and what does it represent? All right, so here if we talked about pages per hour. This is our slope. The way we have it set up here on our graph is that the slope is negative. So here we would say the slope is negative 55 pages, and what it represents is the pages per hour. Okay, so that's how many pages left per hour. All right, and then it says write an equation in point-slope form. Okay, well, we have a point right here. Our point is 4,385. And our slope, again, we wrote that down already, would be 55. So in point-slope form, that is y minus y1 is equal to m times x minus x1. And we'll just plug that in. So we have y minus y1, well, y1 is 385, equals our slope, negative 55, times x minus 4. So that would be our equation in point slope. And now we want to write it in slope-intercept. So just a reminder, we did this in our homework last time. It just wasn't in a word problem. Okay, we distribute the slope. So that would give us negative 55x. And then we would do negative, well, maybe I'll rewrite that again, negative 55 times negative 4. Okay, so that would be negative 55x plus 220. All right, and then we still have our y minus 385. Then the last step would be to get y by itself. So that's really what we need to do when we want to in slope-intercept, is just to solve for y. So we would add 385 from both sides. And it would end up getting y is equal to negative 55x plus I guess it'd be 6. Oops. Add that, would get 5. Here would get 10. We'll carry the 1 and get 605. So that'd be the our equation. Okay, y equals mx plus b. Okay, y-intercept, what is the y-intercept? Well, if we have our slope-intercept, this is our y-intercept. So it would be 0, 605. And what does that represent? Well, you could say something like at time equals 0, he has 605 pages left to read, or you could say initially Jake has 605 pages to read, or something like that, okay? All right, so you want to write something. Okay. What does the x-intercept, I think I need to fix that. What is the x-intercept of the equation? And what does it represent? Okay, so again, we've talked about this several times. If you want to find the x-intercept, y is equal to 0. So we'll set y equal to 0. And we'll just solve for x. So here we'd need to subtract 605 from both sides. Get negative 605 equals negative 55x. And then we'll just divide both sides by negative 55 to get x by itself. Okay. And then you probably want to just grab a calculator and just say negative 605 divided by a negative 55. And that ends up giving you x. Let me do my other color. X is equal to 11. So our x-intercept would be 11, 0. So what is that telling us? How does that represent? Or what does it represent? Okay, so here we would say something about how this is time and this is pages. So you could say after 11 hours, Jake finished the book. Okay, something like that. All right, and then if the rate of change remains the same, how many pages are left after 7 hours? Okay, so remember hours is our x, so we'd use our equation y equals negative 55, and then our x would be 7. Okay, so we just substitute that in for x, and then we'd solve. So again, use your calculator. And that would tell us that we have y is 220 pages left. How many hours would it take to get to 77 pages left? So pages is y, so we'd do 77 is equal to negative 55x plus 605, and we just want to find the time. So we would need to subtract 605 from both sides. We want to isolate x. So we'd have 77 minus 605. So that gives you negative 528 equals negative 55x. And then we'd need to divide both sides by negative 55. And that ends up giving you x is equal to 9.6 hours. Okay? So that's how long it takes you to get 77 pages left. Okay? If you have any questions, please let me know. We'll go over the next one. Okay, so Mr. Mole is left his burrow that lies below the ground. So if we come up with some sort of graph, he started in his burrow. Let's say this is his burrow. We don't know what value that is, but we will figure it out. Okay, so it says he lies below the ground and started digging at a constant rate deeper into the ground. After 5 minutes, so again, X is always time, so minutes. After 5 minutes, it says he is 39 inches below the ground. So since he's going deeper, it's got to be below his burrow. So we'll say negative 39. Okay, put that point. And then it says after 10 minutes, he is negative 54 inches into the ground. So we have some sort of linear equation, constant rate, okay? And basically we have 2 points. We have 5 comma negative 39, and we have 10 comma negative 54. In our class beforehand, if we have 2 points, and we've done this I think in unit 4 as well, if we have 2 points we can find the slope. Okay, so the first thing, well, first off it says X represents, I think we already wrote this down kind of. X is our minutes, and Y represents depth in inches. Okay, I guess you could say this would be time in minutes. Okay, all right, so we want to find the rate of change. All right, so we could use m equals y2 minus y1 over x2 minus x1. You could basically say the difference here is y2 minus y1, and then this is the difference in your x's. Okay, so however you want to do that, it'll be just fine. So y2, negative 54, minus a negative 39, all over 10 minus 5. All right, and then probably do that on your calculator. Negative 54 minus a negative 39. That gives you negative 15, and 10 minus 5 is 5, so it gives you a negative 3. So our slope is negative 3. And what does that represent? Basically saying every minute Mr. Mole digs 3 inches deeper. Okay? Write an equation in point slope. Well, we have 2 points. You could choose whichever one you wanted. Let's do the first point. So we'd do y minus a negative 39 gives you a positive. Negative, negative gives you positive. We have our slope, and then we'd do x minus 5. Write it in slope-intercept form. Okay, we would distribute, so that would give us negative 3x plus 15. And then we would need to subtract 39 from both sides. Okay, we'd end up getting y equals negative 3x, so that's basically saying every minute he digs, he goes down 3 inches. And then we have our b, which would be negative 24. So what is our y-intercept? It would be 0, negative 24. Okay. What does that represent? So his burrow, you could say something like initially he is 24 inches below the ground, or his burrow is 24 inches deep in the ground, something like that. X-intercept, again, if you want to find x-intercept, we set y equal to 0. So we do 0 equals negative 3x minus 24. We'd add 24 to both sides. And then we'd divide negative 3 to both sides. So we'd end up getting x equals negative 8. Okay, and what does that represent? Does that make sense? Okay, again, we do not talk about negative time, so we would say it does not make sense. Right? Because who knows how long he's been in the burrow? Could be hours, months, okay, without digging anything. All right, so if the rate of change stays the same, how deep is the mole after 60 minutes? So how far he can dig in 1 hour. Okay, so again, this would be our x, it's our time. So we'd use our same equation that we wrote up here. So we'd do y equals -3 times 60 minus 24. So that gives us -180 minus 24, which gives us minus 204. Okay? So in effect, he can, well, what is that? 180 divided by 60. So he can dig 3 feet an hour. Okay, and that's kind of impressive. Okay, for a little mole. How many hours? Sorry, this should be minutes. Okay, how many minutes would it take 72 inches for him to dig? I need to fix this a little bit. To dig 72 inches deep. Okay, so again, this would be our y. We talked about y is our inches, so we'd do 72 is equal to -3 x minus 24. And then we would solve. Okay, so add 24 to both sides. Okay, 72 plus 24 gives you 96. And then we'll divide it by a -3. And we end up getting x equals -32. Wait, hang on. Oh, this should be a negative. My bad. Hang on one sec. Because it's already it's deep in the ground. It's already negative. So, my bad. Okay, but same steps. You'd add 24. So -72 plus 24 gives you -48. And then we'll divide that by -3, gives you x equals 16. X 16 minutes. Okay? So it takes him 16 minutes to dig 72 inches, which is kind of impressive. Okay? So anyways, if you have any questions, let me know. We'll see you later.